Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. I would like to thank everyone who has donated to the show. Your contributions help us make the show sustainable. Hired is sponsoring us this week. If you're looking for a job as a developer or designer, then Hired will bring the opportunities to you. Sign up at hired.com/podcastinit to double your signing bonus. Once you land a job, you can check out our other sponsor, Linode, for running your awesome new Python apps. Check them out at linode.com/podcastinit and get a $20 credit to try out their fast and reliable Linux virtual service for your next project. You want to make sure your apps are error-free, so give our last sponsor, Rollbar, a look. Rollbar is a service for tracking and aggregating your application errors so that you can find and fix the bugs in your application before your users notice they exist. Use the link rollbar.com/podcastinit to get 90 days and 300,000 errors tracked for free on their Bootstrap plan. You can visit our site to subscribe to our show, sign up for our newsletter, read the show notes, and get in touch. And by leaving a review on iTunes or Google Play Music, it becomes easier for other people to find us. You can also join our community. Visit discourse.pythonpodcast.com to help us grow and connect our wonderful audience. Your hosts as usual are Tobias, Macey, and Patti, and today we're interviewing Jonathan Peirce about PsychoPy, an open source application for the presentation and collection of stimuli for psychological experimentation. So, John, could you please introduce yourself?
Hi, I'm John Peirce. I'm a lecturer in psychology, an associate professor, I guess, in American terms, in psychology at University of Nottingham in the UK.
How did you get introduced to Python?
Way back in 2002, I was a postdoc in a neuroscience lab, and I was using MATLAB to present stimuli and collect responses from participants. And I was not very sure about the direction MATLAB was going. In those days, they weren't clear if they were going to support Apple going forwards. In the end, they did, but they were wondering whether or not they would ever support Macs or cease support for their Macs. And I started hearing about Python as this other alternative that was free, and the cool kids were having a play. But these were really early days for Python, right? There was no matplotlib, there was no pandas, NumPy didn't exist. So there was a debate between whether we should use numarray or numeric. And later on, the NumPy sort of came out of the burning embers of those two. So it was really early days for Python. But what it had that was really useful to me was it had OpenGL bindings. And so I could write my OpenGL code and get hardware-accelerated graphics right there in a Python script. Whereas in MATLAB, I had to write MEX files, which is like a compiled bridge from MATLAB to C. A bit like, I guess I can't remember the name. A bit like, no, it wasn't C-types. Anyway, compiled files that you had to write for MATLAB, and I didn't want to write those. MATLAB actually improved in many ways, and it did support Apple Macs, and they did get wrappers for various different things. But by the time MATLAB was getting better, I was already in love with the Python syntax, and I moved on. So yeah, it was early days basically, and I just kind of fell in love with the syntax of Python and decided this was a way to go.
And can you start off by telling us what PsychoPy is and how the project got started?
So in 2003, I then moved to the UK and got my own faculty position, and I was starting up my own lab. And PsychoPy then began. So it started off as a proof of concept where I was trying to show other people, look, this is what it could do, and trying to get other people to write it, to be honest. But when I moved to the UK, I started my own lab, and this became the library that my lab used for Python scripts. So we would write code in other editors, and then we would use the PsychoPy library in order to provide some convenience functions for saving data, checking keyboards, presenting stimuli in a window. And gradually that changed. So I put it online. It was on SourceForge as of 2002. But gradually people were sort of sending me messages saying, hi, I saw your thing, I downloaded it, it was cool, but I don't understand, where is it? I installed it and it's not in my start menu, right? Because it was a library and people didn't know what that meant exactly. And so people were struggling also to get all the dependencies from Python and that sort of thing. So I turned it into an app, which was basically just a code editor with all of its sort of dependencies built in, including its own copy of Python, so that people could install an app. They could write their PsychoPy scripts, which used the library, and get all of the dependencies built in. And then it was in their start menu, and they got it, right? So gradually people started using that in the sort of 2005, 2006. We had a couple hundred users, maybe, Python enthusiasts. And then the thing that started happening was that I was getting frustrated because I was teaching to undergraduates who didn't know how to program and wouldn't want to learn Python. I was teaching them how to use other software packages that use like a graphical interface. And I started getting frustrated by that. And the students were frustrated by that too. So around 2008, 2009, I decided I was going to write a graphical interface on top of this library that would write your script for you. You would build your experiment graphically, or you would write the script yourself if you wanted to, but you could construct it graphically in the builder, and it would compile the Python syntax script for you from your visual representation of your experiment. And that was the thing that really sort of changed the numbers of PsychoPy quite drastically. That enabled it to be used by an awful lot of people who didn't want to learn a new language.
And can the output of that builder interface then be modified further?
So you can compile it you can either just press run, or you can compile it to a script and hack the script, but also you can insert into it custom code of your own that can be executed at various different, either on every screen refresh or just at the beginning of the experiment or wherever you like. And so you can customize it as well, which once you've compiled the script and hacked the script, you can't go back to the graphical interface from that, right? So the way of providing something that you can edit code within the graphical interface was that you got these inline code components as well. And all of this was possible because Python does great text handling, right? So we could build a WX widgets application that would run on any platform with very little code change. It would take this sort of graphical abstraction of what an experiment was, and it could just create the appropriate text because of the great text handling of Python. So that part was, well, it took a lot of thinking, I guess, but now when I look back at it, it all kind of just hangs together. It makes sense.
So how does PsychoPy compare feature-wise against some of the proprietary alternatives?
So I think the key there is that Python and interpreted languages and the open source world have meant that nowadays software can be written by the people who use the software, right? So I'm not a software engineer, and I know how an experiment should run. I know how a scientist will think of their experiment. I know even how an undergraduate, a very junior scientist, will think about their experiment. So I think in terms of ease of use, that's where we win. That's where the open source community, where enthusiasts and users develop the software themselves, rather than the traditional model of trying to communicate that to a professional software engineer who's never personally run an experiment and doesn't know what that means, right? So I can actually build the thing the way that I want it to run and the way that I think about my experiment. And so I think that's where we win in terms of features. And in most other things, in terms of sort of high-end features, yeah, we can do a lot of the fancy stuff as well. Again, because of the nature of open source software and the fact that you've got lots of enthusiasts who are contributing. We've now got 50, 60 people who've added some level of code, and 3 or 4 of us who've contributed a lot. And those are various different enthusiasts who will add some high-end feature of their own. So, and whereas commercial software can't just sort of like suddenly add this new thing really quickly and have it out there. So in terms of features, we do really well, I think. And in terms of usability, that's where I think we're doing extremely well, to be honest. Where we don't do so well is in bugs and, reacting to that sort of thing. We're all busy, and we're not professional computer scientists. So sometimes we've added features, but we've not been fixing the bugs for which we've got workarounds, right? So I know that there's this annoying little glitch, but I know how to avoid it, and so I just do. And so sometimes that's the downside of these sorts of projects versus a commercial enterprise. We understand the users better, but also we don't have as much time to fix bugs, and we don't spend hours and hours testing things. So that's that. I guess those are the two main differences.
In the documentation, you mentioned that your project is useful for the fields of psychophysics, cognitive neuroscience, and experimental psychology. And I'm wondering if you can provide some background into how those disciplines differ and what constitutes an experiment for each of those fields, respectively.
Sure. So my own work is in vision science, and that's the psychophysics is this area of psychology where we treat the brain as basically, it's like an engineering, a physics project, and we map its inputs and its outputs and that sort of thing. It's a very dull area of psychology to many people, but that's what I do. And that's where PsychoPy has its origins, was presenting very precisely low-level stimuli, visual things in my case, so measuring your ability to detect something that's barely visible, for instance, that sort of experiment. Then you've got so cognitive psychology would have an experiment where, say, you would test someone's memory to a set of objects, and we'd measure what sort of things impair your memory and what things make you, respond faster. So something, and linguistics blends into this as well. So something like the Stroop task is a task that's very well known in this sort of field, where you present the word red written in green text versus the word red written in red text. Subjects or participants have to report the colour of the letters, but they're slower to do that if the letters are spelling out the wrong word. Okay, so you're slower to respond that you've got red letters in front of you if the red letters say the word green. So that would be a sort of cognitive psychology or linguistics type of study. And again, it revolves around present a stimulus, measure a response, measure your reaction time to that stimulus. Neuroscience might be similar sorts of experiments, but now you're doing that in an MR scanner. So you're measuring the fMRI or bold signal of a participant while they see different stimuli. So there are various different sort of fields around what overall we'd call the behavioural sciences, and they all tend to link to the same sort of experiment where you present a stimulus and you get a response. There's also social psychology, where maybe you'd present images and then you'd ask people to rate them, or you'd ask people's opinions in some sort of a way. And again, you can use the same software to run all of those different sorts of studies.
So do you find that users who have no previous formal programming training come up to speed with PsychoPy quickly? And what are some of the challenges there?
Yeah, for some of our users, that's a real challenge. For those in more neuroscience-based areas, they are probably fairly used to programming because they'll need to do it for their analysis anyway, and they've been used to other things like MATLAB and that sort of stuff. So we've got a huge spread. People in psychology and people in linguistics are typically less likely to be programmers beforehand, and so we've got this quite broad church of people from all different backgrounds, and that's where the graphical interface or the scripting interface really helps. So if you prefer to code and have absolutely every bit of control over every aspect of your experiment, then you should write your script yourself, because the builder is going to be trying to do things generally and can't implement every feature that you can write in code. But then for those less technical users, they seem to be finding the builder interface very easy to use. And I think one of the nice things actually is that along the way, they learn a little bit of the logic of programming as well. And maybe they didn't intend to, maybe they didn't realize they're even doing that. But the builder is kind of set up, it has objects and loops, and objects have parameters, and those can be repeated and changed at various different times. They're essentially learning the basics of programming, but they're doing it in a graphical interface rather than line by line of code. They're also, as they start to make those experiments more advanced, they'll want to add in little snippets of code, and it might be the odd line or two that just, makes the next stimulus depend on the previous response. and that's something that requires a line or two of Python code. So they're comfortable with adding a line or two, and they don't consider that programming. There's nothing to be frightened off. But I think with a lot of people, if you tell them that they're going to learn programming, that's just too terrifying a task. Or if you tell them that they're going to write a script, it's too big a thing for them to imagine. Whereas if they start off just writing the odd line or two here and there and learning to hack a little bit something that's already done, then they get sort of eased in. I think we do both things. With the builder, we manage to support people who don't really program and who possibly never will, but also we sort of ease people in a little bit to programming as well. I guess also, I now run quite a lot of workshops and that sort of thing, and we spend a lot of time training people. I've taught people from right the way from undergraduates, PhD students, and professors how to program in Python on to some level, and I guess it comes back again to that thing that I'm not a hardcore computer science trained programmer. My background, I did a degree in psychology, and I can empathize a bit more with a novice programmer because I remember what it was like to be that, and maybe it's a bit harder for a more sophisticated programmer to be training people who don't have that sort of a background. They can't imagine what it's like not to understand the difference between a variable and a string and that sort of thing. So maybe it's my lack of computer science background that means we can do this a little bit better.
That's great. I think it really speaks to one of Python's core strengths in that it really seems like, for whatever reason, whatever its attributes, the language really allows itself to be picked up comparatively easily, at least compared to other programming languages, by folks whose primary occupation or focus is not programming. So that's fantastic.
My experience is that the starting point for quite a few users, it's easier with an absolute beginner to teach them MATLAB for the first few hours, where they don't have to worry about things like, was it an integer or a float, right? It just does the right thing, and they don't have to think about different types. They don't have to import their libraries and that sort of thing. But very quickly, I think you're right, that after that first couple of hours, they get it. And then if you then try and show them about MATLAB, they get very frustrated that it can't do all of the things that they found so easy in Python. So I've had some great experience with teaching people Python, and if they've not learnt a language before, they get into Python usually fairly quickly.
Yeah, and I think that your comment about having the ability to work against a known good piece of software and then just add some modifications here and there is definitely a great way to introduce people to some of the different concepts, because they don't have to start off staring at a blank page and say, okay, well, where do I begin? Because it's already begun. They just need to continue it along, and then that will provide greater confidence when they do go back and have to start it with a blank slate.
So the other thing that we do, this within the application, as I say, I sort of provide this code editor, and it's not as sophisticated as, say, Spider or lots of the other more professional, dedicated editors, but it has a menu that says demos, and it has so users new to programming can look at the demos menu and see a whole range of relatively small, digestible demos that show one aspect of the software in a unit. And there's a big green running man that says run, So although a lot of users then will want to go on, or more experienced users from other programming languages will want a more feature-rich editor, to a new user, they get something that's very simple with a green running man and it just works. That's the aim. So it provides them, again, with a very simple inroad. And lots of other users, I'm sure, are just going to use PsychoPy. Those sophisticated programmers will just use PsychoPy as a library, and they'll use their own Python installation and their own editors, and that's great too.
Yeah, and I'm sure too that by having the demos, which are going to tie into a discipline that they are familiar with, will make it easier for them to then understand what's actually happening in the Python code itself.
Yeah. So we've got a range of sort of from very small unitary things like how do I present a sound to sort of full-fledged experiments. We've got quite a range of levels there.
And can you describe the internal architecture of PsychoPy and how you approached the design and how it's evolved over time?
Yeah, so evolved over time is very much the key phrase there. Design is, there have been moments where we've really designed the architecture, but at the core it's this library. That's the basic thing. So it's a library which has stimuli that might be visual or might be, there might be classes for handling your trials and saving your data and that sort of thing. The key, in terms of architecture, the key step was this development of the builder and how that was going to work. So there was an abstraction layer that I started, and this was very much designed. So I started thinking about what are the key aspects of an experiment and how should that look in terms of a Python dictionary, essentially. And then how do we save that dictionary to a file and how do we represent that dictionary visually? So what we've got is an experiment can be built in terms of a number of components, like a text object or a keyboard or a image, and those get combined into routines. Those routines are basically just a list of components, but the component knows within that routine when it should start, when it should stop, and what its parameters are. Then we've got a sort of a flow that combines those routines in various different ways. And that's essentially the whole thing. So the flow is a list of routines that happen in a certain order, and that's all there is to it. It calls each routine and says, write your code. The routine then calls each of its components and says, write your code, and then goes to the next routine in the flow list. So by having these units that are combined in various different ways, it turns out that you can make quite a rich structure of experiments. And you can have loops on the flow that cause something to repeat. And of course, in terms of the Python code, that's just adding an indent level, essentially. And the end of the loop on your flow just dedents the code again, and we carry on to the next piece of code. So in terms of the graphical interface, writing the code, it was all relatively straightforward. There's this abstraction layer, which is a dictionary containing some lists. And that gets saved to a data file, and we sort of created an open standard, not a data file, sorry. We created an open standard sort of experiment file, which is an XML formatted file that essentially just stores these lists and dictionaries with their various parameter types. So that can be loaded into, or potentially, I don't think anyone's written anything that has loaded these into other pieces of software, but that's agnostic about what the software is that's using it. It could be loaded into another piece of software, and it literally just defines what sequences of stimuli and keyboard, etc., get used to create an experiment and how those iterate to create a full study. It's really a graphical interface that writes the code. So that's the key part. Builder writes your script for you, and it literally writes a Python script. Going forwards, and I think we'll come on to this later on, but going forwards, we're actually now having it output a JavaScript script instead. So we will be able to, this builder interface that defines your experiment doesn't need to care about what language the script is that it writes. It just has these chunks of code, and those chunks of code could be in any syntax you choose.
So how easy is it to extend PsychoPy with new types of stimulus?
Super easy. That's straightforward. Either in the library, you can add your own Python classes or subclass existing ones. That's all very straightforward. The rendering code is all pure OpenGL, so some people have, done some transforms, for instance. They've got some particular unusual display, like a huge curved screen rather than a regular computer display. So they've had to subclass the window in order to add some alternative spatial transform to their window, for instance. So all of those sorts of things are really easy to do. Or just adding a new stimulus. Someone just recently contributed a new stimulus is essentially a visual button that people can click on within the regular OpenGL screen. So all of those things can be added very easily in the library, but also in the builder. The builder is completely modular. You can add your own components, and all that a component needs is it needs to know what its pieces of code are that need to get executed at the beginning of the experiment, at the beginning of a trial, on every frame, at the end of a trial, etc. So it has 6 pieces of code, and if it knows what its initialization code is, then the builder will call that initialization code for each of the components in turn. And so all you've got to write for your new component is how should my object be initialized, and you're done. So yeah, it's really very extensible. And some people then go on and share those extensions that they've made with the rest of the community. I'm sure loads of other users are kind of shy to share their code, and they'll keep their component just in their own lab, and that's fine too, So, but it's being widely extended.
That's great. So, what are some interesting challenges you faced when implementing PsychoPy?
The interesting intellectual challenge has been, how do you create this sort of abstraction of an experiment that isn't about line? So working out what that should look like in a way that's really general, and that would be easy enough that a first-year undergraduate in psychology who's a technophobe can still create their study, but also that a professor in neuroscience is quite happy to use the software to create their fancy experiment as well. So to generate something that was sufficiently general that it could run a real scientific study, but also sufficiently easy that a new user wasn't terrified. That's been the big interesting challenge, and that's been a lot of fun trying to get those things right. The more frustrating challenges have been trying to support multiple platforms and trying to keep a track of all of. So we have lots of dependencies. I didn't want to write my own library for loading videos and another one for presenting this, I don't know, other sound stimulus or something like that. So we've used a lot of other dependencies, and those keep changing, and that's quite frustrating. That I've spent a lot of time. Just each time that we provide the new distribution, the new large application, I have to go and dig through what's changed, and I don't know, Pandas has changed its input call or something like that, and something else has changed. It's become 64-bit only or something, and so maintaining those has been quite hard. And I'm afraid we do have releases where we push out the package and then someone comes in and says, oh, but the library has changed, or one of my dependencies has disappeared out of the package, and it's because I've had to rebuild everything from scratch at some point. That's been the hardest part and the most frustrating part as a developer, keeping on top of many different platforms, trying to test on all of the different platforms. So we do have a test suite, but a test suite only really works for the library. It's not very good for an application, because testing the sequence of button clicks is on arbitrary display shapes is a really hard thing to do. So a lot of the application side isn't tested in the test suite, and that means that I'm afraid sometimes we release things where I haven't gone and pressed all of the buttons on Linux and on Windows 7 and on Windows 10 and on Windows 10 64-bit, you know what I mean? So sometimes we break things that way because I haven't been able to test all of those things. That's quite frustrating for me and for the users. But on the whole, I think the ship is gradually moving forwards, not backwards.
That's great.
I should point out that I sometimes talk about but the other users and the other contributors are huge in this aspect, and a lot of people will submit quick fixes. Users will notice that something's not working, and rather than saying it's broken, they will come back and say, hey, I've discovered that this doesn't work anymore, and I've dug around, and it's because Pandas now needs this new argument. So here's the change on GitHub, and I can just do a pull from their pull request on GitHub, and GitHub has made my life so much easier in terms of that sort of thing. And it means it's really genuinely a community, so I should stop using I altogether. It was I for about 7 years, and now when you look at the contributions, some of the releases don't have any contributions from me at all. I just merely put it all together and release it. So yeah, the community has grown really strong around it.
Well, that's a testament to your hard work on the project that made it a success, that made people want to contribute. So one thing real quick, you mentioned previously that in future releases, PsychoPy may emit JavaScript. Is that, at least in part, an attempt to deal with some of these difficulties in integrating third-party multimedia libraries?
That wasn't the aim of that, but it has crossed my mind that increasingly some of the problems will get solved. And so running a study online in a browser was something that people have been asking for that as a feature for a very long time. And I've always just written back and said, no, PsychoPy is about hardware accelerated graphics, and it needs that in order that an interpreted language can do things in real time. And so timing precision is really important to us. We need to know, and most pieces of software wouldn't know, exactly when did your screen refresh, for instance. And we want to know, did I manage to get my stimulus drawn before the screen refresh occurred? Because if not, then our timing went wrong. So I basically always push back on these users that were requesting a web interface, because I was just like, no, the browser can't do that. It doesn't have the graphics hardware, to be able to perform at that level with that level of precision. So I always just said no. And then relatively recently, WebGL has changed all of that, and even Canvas to some extent in the HTML5 Canvas code has changed a lot of that. And you can actually now, with WebGL, you can use OpenGL shader language in a browser. It's crazy what you can do. And suddenly all of that sort of performance issue that I thought we would have is disappearing, and the performance will probably never be quite so good in terms of how quickly you can get responses, and we'll never be able to connect to hardware like parallel ports and that sort of thing from a browser. But for an awful lot of studies, suddenly the web actually has the performance that we might be looking for. So that it was that change that was really driving this potential of creating JavaScript. But as a side issue, I've then started looking at the way that those things are done, and particularly a library called Pixie.js that I've been looking into a lot lately. And wow, it makes all of that media stuff really easy, and a lot of the things that have sometimes caused me a lot of pain might get a lot easier. But it will require quite a lot of testing as well. You know, when you ask a sound to be played in your browser, how long does it actually take for noise to come out of the speakers? That will take a lot of testing for us to know exactly how good it is, and it may be that the performance is still not that great, and we'll have to look into that a lot.
And I imagine that by being able to target the browsers using the same builder interface would potentially drastically increase the size of experiments that can be conducted, because of the fact that you can just publish them to a website and have people interact with the experiment without necessarily having to be in a lab environment.
Exactly. Yeah, it's a game changer for two reasons, actually. One is because you can send an email around and get people to participate that you've never met, that you didn't have to bring into a lab and individually get them to sign off the forms and sit them down and explain you just send them an email. And so technologies like Mechanical Turk have been quite big recently in getting people to essentially be enrolled in a study and paid by Amazon via Mechanical Turk to be a participant in a study. And suddenly studies are having tens of thousands of participants, whereas if you were going to run those participants yourself in your lab, you'd have maybe 100 if you've got enough time. So yeah, it's a game changer from that perspective. But also it means that you can, if we're running a study in a web browser, we can run a study on any device. Right now, PsychoPy needs something that will support Python and Piglet and OpenGL and all of those dependent libraries, and that means it won't run on an iPad, and it won't run on, well, it will run on a tablet if you want to go and install Linux on your tablet, or Windows, I guess, or Windows Surface. So suddenly move it to a browser, move it to a website, and your existing experiment that you created in Builder can now be compiled to a website, but it can be run on any device, whether it's a phone, whether it's Android, whether it's iOS. All it needs is something that supports JavaScript and a web browser. So yeah, it's a game changer in many ways, and it'll be very exciting to see how that pans out.
Yeah, and I think another thing worth mentioning too is that by having that greater reach and potentially much larger audience, I imagine it's easier to prove statistical significance, and by the fact that you do have such a larger corpus of data to work with.
You can dig around and find things more with very large numbers. I'm a little bit concerned, actually, to some extent on that score, because you could also find yourself reporting a lot of noise, or tiny effects that wouldn't have been significant when you look at a few hundred people are significant in tens of thousands of people. But actually, if it's that small that you needed tens of thousands of people to measure it, maybe it's not big enough that we should be caring. That's a personal query.
Yes.
That's a scientific issue.
In looking through the documentation, I noticed that you support a number of different formats for the output data, including Pickle. I'm wondering what are some of the most popular analysis tools for users of PsychoPy?
Yeah, sure. So Pickle file is something that we save as a sort of safety net, and it contains an awful lot of information. So it contains a copy of your experiment, which Pickle is sort of it's literally a copy of the study that you ran as the data were collected, and it's the Python object just pickled. So that's a pretty useful thing that can, for instance, be used later on to save out some of the other formats as well later on. So if you've accidentally ruined your CSV file, which I think is what most people would use for their analysis, you can go back to the Pickle file, recreate the CSV file from it, because it's just a copy of your experiment. Or if you forgot one of the parameters of your study and you accidentally didn't save it in the CSV file, then you can go back and dig out what the actual parameter was from the script that has been saved within your Pickle. So that's a sort of a belt and braces kind of a data format that I suspect most people aren't using for real analysis. Although you can load up that Pickle file and you can use NumPy or Pandas to go and analyze. I mean, the data are then saved in NumPy arrays within that file, and so you could certainly use that way if you like. We also output a CSV file, so a comma separated value file that most people would use. It's a trial by trial, what happened, but you have to tell the CSV file, or you have to tell PsychoPy what to put into the CSV file. So what variables are of interest to you, and it's going to load those as headers in the file. So Builder will try and do that for you automatically, but maybe there's something that you wanted to study within your experiment that you need to tell Builder that it needs to do manually. So occasionally people will get that wrong, and then that's where the log file comes in. So that we also output a log file, which is just an automated stream of events happening in your study as it occurs. So I've just changed the stimulus to this, I've just done that, we've just started a new trial, the subject has just pressed this button. Now that's not always easy to analyze because it's a stream of way too much information, just in chronological order, and it doesn't know the semantics of your study, it's just a chronological stream. But that's very useful if you've forgotten to do something, that you can go back and check all of the details, and you could write a script that parsed this nasty log file and dug out the data that were critical to you in most cases. So we've got various different. There's also an Excel file which we basically don't recommend anyone use. You can save your data in an Excel file if you so desire. In terms of what people are using for analysis, I guess a lot of our users would be in psychology and they would be using SPSS. We would naturally try to encourage people to use either Python or R. So they might load their data in Pandas, or they might load their data as a table in R, and the CSV file is designed so that either of those packages would allow you to load your data in a very easy step and start doing analysis on that. So that's what I would naturally imagine most people to do. Again, I used to do my analysis on the Pickle file using NumPy arrays because PsychoPy predates Pandas. And so Pandas was a new thing to me that I subsequently learned is really useful.
Yeah, Pandas is a somewhat recent entry on the scene, though it seems to have gained a lot of following because of the fact that it's fairly easy to use, and two-dimensional arrays are a fairly large portion of the problem space that people were using NumPy for, and it adds in a lot of niceties on top of that in terms of the data frame format. And I was going to ask if you've looked into the use of the Feather library for being able to add that interoperability between Python and R for people who want to do their analysis in R.
I haven't actually. I haven't personally worked with the Feather library at all. I haven't really used R myself. I'm still using Python because I've now got all of my scripts that will do various scientific analyses like bootstrapping and whatever and simulations in Python. I've never had the need then to go and learn R. So, but it's something that a number of our other users are certainly using R a great deal, and I suspect they will be digging around in Feather as well, but I haven't got that far yet myself.
And how is data input typically managed? I'm wondering if PsychoPy supports automated readings from test equipment, or if it's something that's the responsibility of the people conducting the experiment to control the data input.
Yeah, no, typically it comes from the experimenter writing the code to handle the controls or whatever. A lot of it obviously is very straightforward. I mean, most of the inputs are coming from things like keyboards and microphones and mice. So that's all easy enough. They might, if you've got some hardware like I mentioned MRI before. So if you're doing an fMRI study, then you need to monitor probably the trigger pulses that the device is sending out. So a scanner will send out a pulse every, say, 2 seconds to announce that it's just about to start creating a new image of the brain. And so you need to detect when those things occur. But those are relatively straightforward things. They're either a serial input or a parallel port input or a keyboard sometimes that they'll simulate pressing a key. So those are all relatively straightforward. And it does come down to the user writing their code to interface with them. Depending on what sort of hardware, we might have them built in, and for some you might need to add your own. So eye tracking is another good example where we've got support for, 6 or 7 different eye trackers, and if you're using one of those, then you can plug into a sort of a unified API and say on each frame or on each trial, find out what the position of the eyes was at this point using one set of function calls. So we've got built-in support for quite a few, but if you've got your own eye tracker that's different to one of those, then you might need to use your own custom Python code. Hopefully your hardware supplier will support Python as well. So it depends on what particular devices you're using.
And I imagine that because of the fact that timing is of such critical importance in these experiments, that it is certainly necessary to make sure that those data inputs are being fed through the PsychoPy program so that you can correlate the input times with the stimulus times.
Yeah. So we've got essentially 2 different ways of doing this, and one is just using the traditional Piglet sort of, which is the graphical library that we use. It's like Pygame for those who don't know. So we might be just, say, recording key presses using that, which is really easy to do, but isn't actually super precise. So typically you'd be updating your stimulus on every frame, and that means you're tied to a refresh rate of, say, 60 hertz. So if you're checking the keyboard once per frame in part of that flow of code, then of course you're only checking the keyboard every 16 milliseconds. And so there's an alternative system that we have, which is a library called IO Hub, which is now really very much integrated in PsychoPy. It's really a part of PsychoPy. And that was written by a contributor who comes from the eye tracking world, Sol Simpson. And he has written that to essentially be monitoring hardware in a separate process and passing G events back to the Python. Well, it is a Python process as well, but it's passing events back to the PsychoPy main process. And this avoids the global interpreter lock and allows you to run your hardware acquisition, your data acquisition, and outputs at times on a separate process, on a separate core, if you assuming that you've got a multi-core machine. Now that has methods for synchronizing in both directions. Either it can save its own data file, so it also supports a data format of its own based on HDF5, and so it can stream data at a kilohertz, say, which is what some eye trackers would be using. It'll stream data at a kilohertz down to an HDF5 file, but also you can poll it from the main PsychoPy process to get some snapshot of what's going on, for instance. So we have ways of doing that, but using IOHub, it's a lot more intensive in terms of the user has to work a little bit harder to get that all working. It's more complicated. It's running a separate process and sending events backwards and forwards. So for simple studies, I think people still tend to use the basic get keys kind of calls, even though those aren't quite as temporally precise as using IOHub.
It strikes me that this kind of framework with all this eye tracking and millisecond scale input and rich visual display capabilities could also be really useful outside the field of psychology for things like UX researchers or things like that to test new input paradigms and the like.
Yeah, I don't have statistics on where this is being used outside psychology, which I'd really like to know about, actually. Anyone who's using PsychoPy not in the world of academia, I'd really like to hear from you how you're using it, because it helps me to persuade people that this is a useful endeavor outside academia. Certainly some people are using it in other things, like in clinical research and in developing hardware, I believe. But I get to track how many people are using PsychoPy, but not in what way. So I just don't have very much information about that. Certainly I've been amazed at the variety of experiments and the variety of ways that people have used it. I had in mind a very limited set of use, particularly for the builder, and people have gone way beyond what I ever imagined and creating quite elaborate studies that I hadn't really pictured being done.
What are some of the most interesting experiments that you're aware of having been conducted using PsychoPy?
Oh goodness, that's a really hard question to answer. Thousands of studies have been run, but I don't follow what they all are. So it's a very hard question to answer. One of the demos that we actually supply that I think is really fun is called the Balloon Analog Risk Task. And that's a way of measuring your risk-taking behavior by allowing you to blow up a virtual visual balloon, and it will pop at some point. And the question is, how far do you keep on blowing it before it pops? You get more score the bigger the balloon gets, but if it pops, you get nothing. And so it's a way of measuring your risk-taking by investigating how far you blow up this balloon. So that's actually just one of the demos in PsychoPy, and that's actually kind of a neat way of showing the level of flexibility that we have, and it's an interactive study. It's not a traditional sort of I present a stimulus, I collect a response. You're growing this balloon. So that sort of demos a little bit the range of things that can be done, and maybe one of the more interesting types of studies. There are also things like the implicit association tests, or IAT. So PsychoPy has used a fair bit for that in various different labs, which is a sort of test where you're trying to understand. Someone has an overt opinion of a particular stimulus. They say that they like this thing or they dislike this thing, and you're trying to work out if that's true. So you can present images of various different stimuli, and you ask people to respond about likes and dislikes, and you measure essentially if you know that they're wanting to respond that they like this thing that they actually don't. You can measure the reaction time to their response in a speeded task, in a rapid stream of stimuli. When you're intending to respond one way, but actually you feel something different, then it delays your response. So that would be an implicit association test, and that's sort of one of the myriad things that PsychoPy is used in. But it's being it's being used in so many different brain scanning studies or brain-computer interface studies as well. So people that are using PsychoPy while measuring EEG, so electrical signals on the scalp, and trying to control the stimulus by using the electrical activity on the scalp. So that's called a brain-computer interface, or BCI. Some people are certainly using PsychoPy for that sort of thing as well, because it can present stimuli very rapidly based on inputs. So there are quite a range of different things.
While I was reading through the docs, I found the page describing the integration with the open science framework for sharing and validating an experiment and the collected data with other members of the field. I'm wondering if you can explain why that's beneficial to the researchers and compare it with other options such as GitHub for use within the sciences.
Sure. So this is a new development for us, and it's an interesting new direction. The idea is that when I run my study, A, I want to share it with my collaborators in other departments, say. B, I want to share it with other computers in my lab. And C, afterwards, I potentially want to share that with the rest of the world in a convenient way that other people can go and download my data. Now, the question about so Open Science Framework allows those sorts of facilities. It allows you to store data that either can be private to you but also can be exposed to the rest of the world if you want to share it and make it public. Now, that I didn't find their interface all that intuitive, although that's what it has over GitHub. So the idea is that for a lot of scientists, GitHub is really written for coders, and they don't know what Git is. So the idea for them of getting a GitHub account and uploading something using a terminal tool, although I guess now there are graphical interfaces for that as well, that would put off quite a few scientists that are less technically competent. So Open Science Framework is sort of a way in, particularly it's come from the field of psychology, to allow people to upload, make public, share with collaborators their experiments and their data. Now, I didn't actually find their user interface super easy for a new user. So they actually had provided some funding for us from the Center for Open Science, who wrote Open Science Framework, to allow us to synchronize files directly from within PsychoPy. And so you can now go to the projects menu as of the new version that was just released yesterday, 1.841. You can go to the projects menu, you can take a folder from your local machine, and you can create a project on Open Science Framework based on that folder, and you can just press sync, and it will keep those projects in sync. You can also search for it from another computer and download that project, and again, you can just do syncing from one machine to another within your lab. And then at some point, if you want to, you can go to Open Science Framework and click a button to make that public. So it's about trying to enable users who are a bit less tech aware or don't want to have to learn lots of different interfaces and lots of different technologies. They've got the hang of PsychoPy. There's a menu that says projects. They can go to that menu and either search for an existing experiment. That's what I'm hoping in the longer term, is that people will make their experiments available online. Other users will be able to go and search for, show me an existing implementation of the implicit association test. And then I can download that and build my work on that, and it will speed up science. That's the idea.
And I imagine, too, that it will increase the transparency and repeatability of some of those experiments, too, while at the same time creating the provenance for the data so that it's easier to go back and understand where the statistics come from when you're publishing the results of your experiment.
That's definitely a great goal scientifically for Center for Open Science, and for me, I would love to see that happen. I don't think that's what's driving the individual scientist who's wanting to upload their data. So right now, that isn't having people examine your data and look for flaws isn't an incentive to most scientists. But being able to share it and encourage. So in reality, getting other people to see your experiment and your original code and build their study on it that improves the visibility of your work and gets more people to base their study on your work, which means you get more citations for your paper. So that is an incentive for a scientist that they should be aware of. They should be trying to increase spin-off projects from their work. And this publicly sharing your code as well as your data allows people to create spin-off projects more easily. And that is something that a scientist should care about, whether or not they do it for the altruistic reason that they want science to progress well, and it's all very good of you to feel that you want people to be able to examine your data and look for flaws. People, in reality, it's a lot of effort often to make your data available in a format that other people like and all that sort of thing. So people are often quite shy of doing that unless there's a clear incentive. So I try to focus a bit more on why it's good for the scientist, on the individual scientist, as well as the fact that of course I do believe that it's good for science as a field as well.
Do you have a roadmap of features that you'd like to add to PsychoPy, or is it largely driven by contributions from practitioners who are extending it to suit their needs?
Both, very much both. There are lots of things that I would love to add and haven't had time to do. So PsychoPy's development has been driven by either things that my lab currently needs and I want to get in there, or that a contributor's lab needs, and so they're going to go and add that feature because they need it for their study right now. And that's the best way in many cases for things to be added. There are lots of other things that I would love to add, and if I had time I would, but my priority has to be with my PhD student and that sort of thing. So there's a mixture going on. There's also an issue that although I would love to add a certain feature, so right now I'm in discussion with someone who's wanting to contribute stereo displays and enable PsychoPy to support shutter goggles and that sort of thing better without the user having to write particularly hard code. So how do we make that easy for the user, and how do we support 8 different forms of stereo outputs from a graphics card? Now, I'm not the right guy to write that code because I don't have any of that stereo kit. I don't have a TV with shutter goggles that allows me to work on that, and my lab isn't doing that sort of study, so it's never going to be the top of my priority list. And it would be very hard for me to go and test that rigorously. What we need is a user who runs those sorts of studies, who knows more about that technology, and who needs it in their next study. That's the way that the code gets best written. And that's exactly what we've got going on right now, is that there's someone coming to us. They've been using this sort of technology for a long time, and they know how to implement it. Well, maybe with a little bit of support from me about how does the PsychoPy engine currently render things, so that we need to talk a little bit about how to interface his module with mine. That's fine. But that's the way that most of the code has sort of evolved. Or take, for instance, the rating scale. That came from Jeremy Gray, and I've never done a study that involved a rating scale, but he does them all the time. So he wanted to have this stimulus available to make it easier for him to run his studies, and that's how it got contributed. There is a roadmap as well, though, and there are things that I do very much intend to get done, either me or someone, or ideally as we get bigger, we will hopefully have funding options and we will have ways that we can pay people. So far we've had very, very small amounts of money from a few places that are willing to contribute to our open science drive. But one of those things is absolutely the development of web-based experiments and the building of the JavaScript library. Again, I'm not the right guy to write that code. That's not something I've known much about. I've not worked very much on that. So I would have to learn a great deal about JavaScript to write that myself. But we can get other people, probably hire other people. So we've been working with a company called elixir.com, and they've been writing the sort of JavaScript library that's the equivalent of the PsychoPy Python library. So that is something that will for sure be happening, and hopefully that will be over the next year or so, we've got that in a proof of concept right now, and over the next year, I'm sure we'll be supporting full experiments in a browser using Open Science Framework to save your data, and using Builder to generate the web files that you need to do that. One of the things that I'm really keen on is making Builder better at detecting when a user is about to do something that's not wise. So right now, you could ask Builder to draw your stimulus smaller than a pixel, or 4 meters to the right of your screen, or with an invisible texture, and PsychoPy won't complain. It will just fail to draw anything, right? And to the user who gets no stimulus appear on their screen, that's confusing. So one of the things that PsychoPy needs to do is detect and do an integrity check of your experiment and say, it looks like your stimulus is about to be drawn smaller than a pixel. Is that really what you wanted to do? And just provide little warnings like that. That sort of code, again, it's the sort of thing that, because my lab doesn't need it, because experienced users know what's going wrong and they won't make those mistakes, it's hard to make a priority, but it's something that I feel is really important, that will prevent people from making silly errors, including me. I make silly errors in my own experiments as well, and I would like PsychoPy to warn me, you're about to do that thing again that you've done 1,000,000 times before and you still haven't learned that that's wrong. So that's one step. That's another thing that's important for the future. Improving precision is always one more thing that we're always trying to work to get faster playing of the sounds, faster rendering of large movies, especially as we go to HD movies increasingly. We've got to improve the precision and performance of a lot of aspects of PsychoPy, and that's something that's just a constant aspect that we're always trying to improve.
So are there any questions that we didn't ask that you think we should have, or any other topics that you'd like to cover before we close out?
No, I think one of the things that I find interesting is this question about open source development versus the traditional commercial world, and software engineers versus academic engineers, but we ended up talking about that anyway. Do you want to talk any more about things like... So one of the things that PsychoPy does that maybe is unusual is this tracking of users, and it's hard for an open source project to persuade people to fund it, and to persuade, in my case, I've got a job as an academic, but I have to persuade people that that's a useful use of my time. I'm not always making discoveries, but I'm making software tools that other people can use to make discoveries. And so sometimes it can be hard to express and persuade people that these projects are important. And that's something that's fairly close to my heart as well. Sometimes getting people to fund a project, they're like, but why would we fund it? It's not going to make any money. Or academics, my seniors would be saying, but why are you doing this and not just paying a software engineer to write the software for you? Or why are you just not using something off the shelf? So those are sort of topics that are close to my heart, and that's why I ended up writing. So as PsychoPy gets launched, it pings a website, and that's what allows us to collect usage data. So we track how many unique IP addresses launch the application every month. And that helps us a little bit to go to potential funders and to go to my superiors and say, look, this is an important thing. We've got 12,000 users. And so that's kind of an interesting topic in a way. But I don't know if that's something that I don't know how to frame that as a question that you would want to include.
You did a perfect job there. And I think that, too, that brings out a good point that as software becomes a more integral piece of academic endeavors, that I think that we are probably going to start to see the paradigm shift a little bit away from the publish or perish, or at least recognizing that developing software is a form of publishing, as is evidenced by the fact that a lot of these scientific open source projects are actually cited in academic works. I know that you've got a citation reference in the documentation for PsychoPy, and similarly for things like SunPy and AstroPy.
Yeah, that's one of the interesting things, is trying to track those users where the citation count on that paper is, I don't know, something like 600 people, something like that. But I know that monthly there are 12,000 users. So there's an order of magnitude discrepancy there that is interesting, and presumably it's that citations follow on gradually later, or people are using the software for all sorts of other endeavors. And when I mentioned earlier on about wanting to know about non-academic uses, it's because in the UK, this, by many classifications, doesn't actually count as having any impact. So the UK counts impact of a scientific of an academic endeavour as when it affects society outside academia, or when it raises money. And because I don't sell it, and because the people using it are academics, tens of thousands of users don't count as any impact, so having one person using it in the clinic for non-academic use but to find patients counts a lot more, it turns out, than tens of thousands of people teaching their students. So we've got these broken kind of incentives in many ways, and those are frustrating for me. Those are topics that I find interesting. Let's put it that way.
This comes back to a recurring theme that we've seen on our podcast. If you're using a piece of open source and you love it, and you know it's making your life a better place, and you're enhancing your job performance, tell the people who are in charge of that project about it. Drop them an email. It takes 5 minutes to say, hey, thank you very much. I'm using it for blah, blah, blah. And it means so much to people like Jonathan here, slaving away, building this incredible stuff.
Yeah, very much. And certainly while writing papers like journal articles versus writing software, I found it interesting when I go to a conference that I do get people come up and say, oh, you're the guy who writes PsychoPy. That's great. I love that. That's brilliant. And it's really nice. And no one's ever come up to me and said, hey, you're the guy who wrote that paper on adaptation to plaid visual stimuli. And I really love that paper. So, it is motivating having individuals come up and say that they like your work. And that actually, for a lot of open source developers, is, I think, what drives them. They like to feel that even though they're not being recognized financially or in terms of other more tangible methods, hearing people say they like your software is definitely what gets a lot of us out of bed.
And on that note, what are some of the best ways for people to get in touch with you and let them know about their use of PsychoPy, or follow what you're up to and how things are going with the project?
We've just recently switched actually from a Google group to Discourse. So Discourse is an open source forum product, and we've now got a forum on discourse.psychopy.org. That's been brilliant. That's something that I hadn't realized actually how much we needed a forum rather than just a Google email list. So actually that's the best place to get in touch with the group. That's if you're writing your own open source projects, then or just wanting an online discussion, I would also recommend having a look at Discourse, because it's a pretty awesome package.
Yeah, that's what we're using for our forum for the podcast.
Okay, yeah, it's really neat. It does everything right.
Yeah.
And from our perspective, it does things like if a user starts typing a new post, but it looks kind of similar to a question that's already been answered, then they get a very clear flag saying, have you looked at this post? Because it's quite similar to what you've just written, which hopefully means that we're having to answer fewer questions, that people will find existing answers instead. So things like that, it's really neat.
So with that, I'll move us on into the picks. And my pick today is the book Hackers, Heroes of the Computer Revolution by Stephen Levy. I listened to it a week or two back and thoroughly enjoyed it. It's an interesting way to get some of the history of early computing and how people who were working outside of the intended frameworks of the hardware sort of pushed the industry forward and introduced a lot of new innovations that might not otherwise have happened. So definitely worth a look for people who are not who weren't there to experience it firsthand. So definitely recommend giving that a read or a listen. And with that, I'll pass it to you, Chris.
That's a great book. I read it decades ago. Man, I'm old. My pick this week is an iOS application. Unfortunately, there's no Android version right now. It's called Castro, and it has really just made my podcast listening life a much, much better place. Rather than using the model of you subscribe to these podcasts and therefore you will listen to every episode that they produce in order, it treats it almost like an RSS reader, like Feedly or something like that, where you have an inbox and new episodes are presented to you, and you can tell it, this podcast is just so good. Just cue it. Don't even bother. But for others, you can say, put it into my inbox and let me choose. And you can say, oh, that episode's interesting. Add it to the front of the queue or the back of the queue, or archive it. And episodes that you archive don't just go away forever. You can go back and leaf through your archives to see if there's something you actually do want to listen to. It's just great. The interface is phenomenal, and I really love it. And that's my pick. John, what do you have for us for picks today, if anything?
I think mine would I'm just going to go back to discourse. My pick of the week would be discourse for forums, and discourse is a great forum package, open source. Really well written. It does everything right, and they're also very responsive developers. When we found some issues and had questions, they were really good at getting back to us as well. So for any other open source developers or people just wanting a forum in general, I would really recommend you check out Discourse.
Yeah, and they've also made it really easy to get it installed and upgraded and self-host it, as well as having a hosted offering if you are not inclined to run your own server for it. So we really appreciate you taking the time out of your day to tell us about your work on PsychoPy. It definitely sounds like a really interesting project, and I hope you enjoy the rest of your day.
Thank you very much.